National Ice Cream Day today, and there are many different flavors of math. Let's go ahead and solve some trig flavors of math, which involve the sine flavor, the cosine flavor, the tangent flavor, and also the secant, cosecant, and cotangent flavors. Let's have some fun. And the chocolate flavor. So let's go ahead and look at solving these problems that are out of the back of your book in section 1.5. It says write the secant theta in terms of sine theta only. You have to look at the directions to know your direction in solving this. So I want to first simplify secant theta into 1 over cosine theta, because now I don't deal with the secant theta anymore. I like to think of secant theta flavor, the cosecant flavor, and the cotangent flavor as being unfriendly flavors. Like you may be thinking bacon flavor or something like that, because it wouldn't taste very good. But the friendly flavors would be like sine, cosine, and tangent. Those would be like vanilla and chocolate and strawberry that we like and love. And so that's what we want to use in this when you're solving these problems. So let's take a look at the friendly ones, which is cosine and sine and tangent. Well, okay, I wrote it as 1 over cosine theta, but I'm not done because it has to be the sine theta. Therefore, to convert that, I have to remember the Pythagorean trig identity. Remember, the Pythagorean trig identity is cosine squared theta plus sine squared theta equals 1, which means if I solve it for cosine theta, I'm going to end up with 1 minus sine squared theta all under the square root, plus or minus. And so that's what I'm going to want to write. 1 minus sine squared theta under the square root, plus or minus. And now this is only in terms of sine theta, which is what the directions say. Remember the different ways of manipulating that Pythagorean identity, and then we want to substitute it in. Going to number 10. Secant theta times cotangent theta. The directions say write in terms of the friendlies, sine theta and cosine theta, and then simplify. We don't have very good flavors. We want to have more appealing flavors, so we got to change them right at the beginning. Let's go to 1 over cosine theta times, now be careful on this conversion, on this substitution. I have cotangent theta, I want to convert it, but if I convert it the wrong way, it's going to make a lot more trouble for me than what I want. I want to replace it with sines and cosines, not tangents. I could put 1 over tangent theta, but that's not going to help me in simplifying. So instead, I go to the ratio identity that says that I want cosine theta over sine theta. By choosing that right identity, now this becomes pretty easy to simplify because the cosine thetas divide out even once. You could leave it as 1 over sine theta. Simplifying, you could also write it as cosecant theta at the end, but either one of those would be correct. It's really uncertain in terms of which is the better form to leave it in at the end. Let's go ahead in terms of 16. We've got a lot of unlikable terms here, and I want to change those. So let's see. Cosecant theta is the same thing as 1 over sine theta with the reciprocal identity. And the cotangent theta, I want to choose the right one to help me simplify. Cotangent theta, the ratio identity on your sheets in front of you should have cosine theta over sine theta. Now you have a fraction divided by a fraction, and therefore you can multiply the top and the bottom by sine theta, or you could multiply by the reciprocal. I'll just multiply by the reciprocal. Notice I'm doing it on a different step. sine theta over cosine theta. Now you're going to see that the sines cancel real nicely, and we're left with 1 over cosine theta. And we're going to see that this somewhat cumbersome fraction boils down to 1 over cosine theta, which is a nice form, and I scream for math on this one because I'm proud of my work. Let's go to the next problem. Add or subtract and simplify. We have two terms, we're subtracting them. The question is, how do you combine those terms? When you're looking at any fraction to combine in a subtraction or an addition, you want common denominators. This cosine theta has a denominator of 1 that's hidden, and so now you're going to see that the common denominator between cosine theta and 1 is just cosine theta. Therefore, I'm going to want to multiply by 1, which is cosine theta over cosine theta. To simplify, it's 1 over cosine theta, 1 minus cosine squared theta over cosine theta. And I see this 1 minus cosine squared theta, which should trigger your memory that you have a 1 and a cosine squared theta. One more time, we go to that identity. That's cosine squared theta plus sine squared theta equals 1. And you hopefully should see that the sine squared theta is equal to 1 minus cosine squared theta. This one step some of you can do in your head. Others of you may need to do this off to the side. But this is the place where the right side is equal to the top. And therefore, the left side can be substituted in for it, which means that this becomes sine squared theta over cosine theta. And because you're on top of things and you're seeing that you can substitute in using the Pythagorean theorem, you should feel good inside and you should be able to have this running through your mind.
I scream for math.
Oops, you did wrong.
I scream for math.
So now we have, on 36, we're going to go ahead and multiply these two terms, and therefore we're going to have distributing 2 different times here. That's 1, and that's the second distribution. So there are 4 multiplications in total, and that's all you're doing on this. It's just like the same thing with binomials that you've done. So I just want to write down cosine squared theta on the first. And this is going to be minus 5 cosine theta plus 2 cosine theta minus 10. These problems are generally pretty easy for students. Cosine squared theta minus 3 cosine theta minus 10. And you can't do anything else with that. You just leave it in that form. And that will conclude this section. Fill out those big rocks and make sure you keep those in front of you when you're looking at these items.